Hey YouTube, what up? Daniel Dallas coming back. Alright, so we on trigonometric identities. We're gonna use double angles, whatever equations or identities we're given. Alright, so that's 5 minutes math, and that's why I'll be sure that's useful formulas. If you want, you can recap them in previous videos. And also the problem 1 that also was in a short video related to the tangent of double angle. So here is the next problem, problem 2, and we need to prove that 1 minus cos 2 theta over the sum 1 and cos 2 theta is equivalent to tangent squared. Alright, let's get started. Let's try to do this problem. It's not really complicated, so that's why we need to work with the left hand side of the equation, and whatever cos 2 theta is staying, we need to plug cos to see the formula of the double angle. So that's why I would write 1 minus, and I'll write cos squared theta plus sine squared theta. Make sure you understand how this works. And with the sum, I'll do the same. So it's going to be cos squared theta minus sine squared theta. Because you don't know in advance which variation of this formula to use, you just write down the straight formula that's you originally given. Okay, so now let's go to simplify. And obviously here, 1 minus cos squared from basic trigonometric identity. Just write down one more time, which is equivalent to 1. I'll express 1 minus cos squared to become sine squared. So in total, we'll get 2 sine squared to theta. Okay, and from there, again, we combine 1 and minus sine squared theta becomes 2 cosine squared theta, 2 hopefully cancelled, and we're left with sine squared over cosine. Oh, if you want, you can write it in this way. Sine theta over cos theta and squared. So finally, it's going to be definitely tangent squared by definition, and we prove because we reached the right side. Okay, so hope you got it. And let's move to the next one. So here's the problem 3. We've got 2 equations and we need to prove both of them. So that's why let's start from the first one. So problem 3 to go. So we've got cos squared of 1 over 2x. And just remember, because on the right side we have cos x of just normal x as the argument, and here you have the half of that. So we can use, we just need to modify the formula for cos x, which becomes basically cos 2x over 2, if you like. So we have double, and angle is basically x over 2. How would you write that? You would write as cos squared of x over 2, because that's the angle, minus sine squared of x over 2. So that's modification you would apply to where? To the right sides. Okay, so if you start from the right side, so you need to arrive to that. Okay, so that's why we'll be working with the right side, and we'll get 1 plus, and here is going to be cos squared x over 2 minus sine squared over 2 x over 2. Okay, so let's simplify, and I again combine the basic trigonometric identity, so you can apply it to whatever angle you have. So that's why you can write even for the half of the angle, so you just write it straight away. And because you again have 1 and minus sine squared x over 2, that becomes cosine squared over 2. So that's why finally we'll get 1 over 2 times 2 times cos squared x over 2, because additionally you had this cos squared x over 2 before. So that's why finally you'll get cos squared x over 2, which literally means that you proved and you got the left hand side. Alright, so with the sine squared, you do the same. So I'll be working with the right side of the equation. It's going to be 1 over 2, and 1 minus cos becomes this. So we'll just need to swap the signs, because we have minus in comparison with the plus before. So we've got 1 minus cos squared x over 2, and because we need to change the sign into opposite due to subtraction, we'll get this. Okay, and now you take this as sine squared x over 2, and you have 2 sine squared x over 2, so basically you'll get this sine squared x over 2, and this is what you're supposed to prove. Alright, so I hope you got it. That was pretty like basics. It's kind of easier, maybe. I'm not sure that's even it's a medium level. I think it's still easier level, but for first trigonometry, and I think it was useful for both A-level students and IB students, so every candidates are welcome. And for general maths, of course, that's just by by default. All right, that was Daniel Dallas. Hope you like that, and we'll be moving to the next problem soon.